Okay, let's start today's class then. Right, so you already have something, you can see that there's something written on the screen, something called as dynamic memory allocation. Okay, so today that's what we're going to learn. What exactly is this dynamic memory allocation? So if we are going to learn about dynamic memory allocation, there must be something else also, which is static memory allocation, because dynamic and static are two words which are, antonyms of each other. Right, so let's get into it and see what exactly dynamic memory allocation means. Okay, so in order to go ahead, let's go back to some of our previous classes where I discussed, the storage classes. And in that class, I talked to you about how memory is partitioned. So let's revisit that a little bit, and then we will try and understand what dynamic memory allocation is all about. Okay, I'm going to draw the memory map once again. So I hope you remember this, that the memory for a C program, right, is divided or partitioned into two main partitions. One is for the text, right, and the other one is for the data. So I think everybody is fine with this. All right, the second part of my story here is that the data segment is again divided into three parts, right? Everybody is clear with this, right? So here, all the code instructions are stored here. Okay, just give me 1 minute. Just give me a minute. Okay, so all of you remember that the code is stored in this side of the partition, and the data is once again partitioned into three different parts. So can you tell me which is going to be the first part here? Do you remember? Let's see who remembers the first part. What is the name of the first partition that we discussed previously? Anyone? Yeah,
Static heap.
stacks, right? So there was one called as stack. The other one was called as a static segment. And the third one, does anyone remember that?
Heap.
Yeah, absolutely. So third one is the heap. Okay, this is a heap. Now we discussed about variables getting into stack. We discussed about variables being allotted into static segment, right? What kind of variables go into the static segment? Those variables which are declared as global variables, as well as those variables which are declared as static variables. What kind of variables go into the stack segment? Those variables which are declared as a local variable, which having a local scope. All right. Now we have not discussed about this heap. Now, what exactly is this heap, and what part of memory, does heap store? What exactly is stored into the heap? Now, that's what we're going to discuss today. Okay. So all the allocations which are done in these two memory segments, that means the stack and the static segments, they are any allocation done in these two memory blocks of the data segment are done statically. Okay, that means memory, any variable which is stored in either the stack or being stored into the static segment are being allocated statically. So they are example of static memory allocation. Okay, allocation. Now, how do we allocate memory statically? Very simple. You declare it. Int A, where will it go? It will go into the stack segment. So I am declaring it statically. Okay. Second one, let's say static X, sorry, not X, static int X. So this is wrong. So let's say static int X. Where is this variable going to be stored in the memory? So this X is going to be stored into the static segment, right? So these two examples here are an example of static memory allocation, where we are allocating these into the static segment. Static segment is that part of the memory where the stacks and the static partitions are done. Okay. Now you see something here. What is that? Now, when you look at a variable here which is being declared, each of these variables have a name. right? Now A is a name, X is a name. Now, how is the allocation of this going to be done? Now, remember, this is a very important concept which I'm actually discussing today. What happens is when we write these lines in a program, int A and static int X, right? When the program is being compiled, the compiler has an idea. The compiler knows which variables you are actually declaring. The compiler also knows the name of those variables. So you know that there is a variable called A and a variable called X. So there are these two variables which the compiler knows from before. Okay. Now, when the allocation is actually done in the memory, right? The compiler what the compiler does is it manages the allocation for this. So the compiler already provides an instruction or has an instruction that for A, because it's an integer, let's say if an integer is occupying 4 bytes, allocate 4 bytes for A and allocates another 4 byte for X, where you have to place this X, place the X or this memory allocation into the static segment, where you're going to place the memory which is allocated for A, place that A into your stack segment. Okay, so the compiler knows about the entire memory which is going to be allocated. And the other thing is these static memory allocations have to be done from before. That means we have to plan for the allocation of these static variables from before. That means when we are writing the program, at that point of time itself, we are declaring, okay, integer A. So we know that A is going to occupy, 4 bytes, 3 bytes, whatever it is, float or character or anything. So static memory allocation means that we have a knowledge, we have to declare the variables even before the program is running. That means you have to plan for them to be allocated before the compilation takes place. So these variables are actually planned for allocation during the compile time. Okay, so the actual allocation of these static variables are actually planned during the compile time. Okay, so when things are happening at the compile time, it's called static allocation. Okay, is everybody clear with what I just told you? Because when I go to dynamic, the static part should be clear. Anyone has any doubts related to what I told you, you can please ask me before I move on to the dynamic part. And if you don't have any issues also, if you've understood, just give me a response.
Continue, sir.
Okay, great. So static memory location we have been doing all this while. So now the question is, like we did arrays also, right? When we declared an array, this array also we knew. And what the best part of this was that we actually had to give some kind of a value there. Like for example, what is going to be the dimension of this array, right? Is the array going to be of size 4 or size 5? Now, for example, like suppose even if we made an array as an undefined array, that means did not specify the dimension, what the compiler already knew, the compiler knew that, okay, there's going to be 5 elements which are going to be entered into those array. So the compiler allocates that 5 memory location for that array. Okay, and everything is being taken care by the compiler. Right. So since C is a structured language, it has got some rules for programming. Okay. One of the rules is that size of an array. Right. Now we know that arrays, basically homogeneous items which are stored at continuous memory location. And we know that the length of the array has to be defined either by us or the compiler does it, and that everything happens before the program goes into execution mode. Okay. Now, for example, suppose I declare the array as size 9. Right. Suppose I declare the array as size 9. But then what happens is, suppose the program starts running. At that point of time, only 5 elements are needed to be entered into an array. So what is going to happen? The 4 indices, the 4 memory locations of that 9 is going to get wasted. Right? So basically, what we should do is we should have reduced the size of an array when only 5 elements were entered. But that is not possible, because if you are declaring an array of 9 elements, the 9 memory locations will be allocated, and whether you enter 1 value or whether you enter 9 values, those 9 the memory locations will be fixed. You cannot change it, right? Now let's take another situation. Suppose there is an array of 9 elements and all the 9 elements are filled. Now suddenly we come across that there is a need to enter 3 more elements in that array. Now what do we do, right? In this case, 3 elements that we need to enter, we actually have to alter the size of an array. So the size of the length of the array needs to be changed from 9 to 12 now, but we have already defined it as 9, right? So it becomes difficult to do all these kind of stuff, right? If we suppose at runtime, that means when the program is running, suppose in place of 9 elements, I need to enter 3 more elements or 4 more elements, and I need to enter 15 elements, right? Now, will the program run at that point of time? Will I be able to manage those 3 extra elements? I can't. Okay, so there is a way by which we can allocate memory at runtime. Runtime means when the program is running, not at the compile time. Okay, now this is called as dynamic memory allocation. So dynamic memory allocation can be defined as a process or a method in which we can change or we can create a variable or we can change the size of a variable. For example, like an array, like suppose we want to change the size of an array from 9 to 12 when the program is running, right? Now all this is basically called as dynamic memory allocation. So in static memory allocation, from before we have to define the variables like int a, static int x. Before we have to define the variable names, and these are allocated in these 2 segments. But if we want to do the allocation when the program is running, okay, when the program is actually executing, and at that point of time you need a variable, or at that point of time you need to change the size of a variable, or for example, if you have an array which you have declared it as like 5, right, of size 5, and you want to runtime, you want to change it to size 10, right? Then we have to do everything dynamically. So this word dynamic here means runtime. Okay, runtime means during execution. Static means compile time. Oh, compile time. All right. So any allocation that you do, any memory allocation that you do at runtime is called as dynamic memory allocation, and all these memory which are allocated at runtime or dynamically will be allocated in this 3rd memory segment, which we call it as heap. So all the dynamic memory allocation is going to happen here, not in the stack, not in the static segment, but in the heap. Is this have you all understood this much? Can I get a response?
Yes, sir. Continue.
Okay.
Yes,
Fine.
sir.
So this concept is very, very important. Please remember, try and understand this concept. Okay. Now I cannot. Now there are 2 important points here which I'm going to, stress on. First thing, when I allocate a memory statically, that means from before I have an idea that this is going to. It's a simple case. Okay. I'll just give you a small, kind of an analogy to this entire thing. Suppose we are organizing a small function. We organize a small function. So there are 2 things that we do. Suppose it's a small event we are organizing, and there'll be some programs which will be conducted on the stage, and we are the organizers. So there are 2 things. We have to plan for the seating, right? Seating means allocation of memory. Now, when we are actually organizing a function, from beforehand, we send invitations. We send invitations to various people, right? So we know that those people are going to be present in the function. So what we do, we send the invitation to them, and before they come, we reserve the seats. That means on the seat, that means there are sofas which are put on the, in front of the stage, and each of the sofa, what we do is we write the name of that person whom we have invited, who's going to come and sit on that sofa. So what we are doing is we are actually declaring a variable, something like int a. What is this a? A is the reserve name for a variable which will be coming, which will be initializing, right, and we have already reserved a place for that. So what happens is when the function, before the function runs, we initialize all the value of A. That means the person who's supposed to come, who has taken the invitation and who's supposed to come, he will come and sit in the memory location which has been, assigned for him. So his name will be there. That means all the variables will have a name. That means if I allocate a memory statically before the execution happens, then all of them will have a name, because we know that, we know when we send an invitation to people, we know their names. So that's how we can allocate the memory location based on the names of people. Similarly, when I'm allocating variables here, I will have the name of the variable like int A, int B, int X, int num, int age, all that I know from before. All right, so this is static variable, a static memory allocation, where each of those variables will have a name. Okay, now what happens in dynamic memory allocation? Now, for example, your program is running. And your function is running, and there's some performances happening on the stage, and all those people whom you've invited have come and they are seated. They're seated. Suddenly, you did not invite me, but I'm a teacher, right? I'm your teacher. So obviously, if I come to your function, you're not going to tell me, sir, we don't know you, please go away, right? Or for that matter, somebody else comes into that function whom you had not invited, but he's an important person. Right. Now, when he comes to the function, you don't have any reserved place for him, right? Because you did not invite him, or you did not plan for his coming from before. So what you're going to do, you would have left some chairs vacant in that. You know why would you have left it? Because in case somebody comes who is not invited but is important, then we will ask those persons to sit on these chairs. And those chairs will not have any names assigned to them, right? So this 4 or 5 empty chairs which you are keeping it as reserved chairs, these are nothing but your heap, right? So heap is that memory allocation where some extra chairs are being kept. Why they are being kept? They are being kept that in case during the execution of the program, if some variables need to be declared, we'll put them on those chairs. So those chairs will not have any names assigned to them. That is, they will not be reserved. Are you all able to understand this analogy? Right? So when the program starts executing and suddenly we find a need to declare one variable, that means we had not planned for this variable, but we need some space and we need a variable or we need some array, then what do? We will allocate that dynamically into the heap. So for example, your function is running and some important person comes into the function. Then you will not allow him to stand there, right? So what you will do, you will direct that person to go and sit at those 5 or 6 chairs which you have reserved, which is the heap. You will ask those people to go and sit there. Now, the important thing is, if you are the organizers, you would not know their names because you did not plan for them from before, right? So once they come, the volunteers will not know their name. So what they will do, they will actually escort these people to the heap, and in the heap, they will make them sit, right? But they will not know the name of these people because we have not sent out invitation cards to them, right? So how will we reach to those people? We will reach to those people by the position of the chair or where they are seated, right? So if suppose we need to call these people to come and have lunch, we don't know their names, so we can't call them or refer to them by names. So what we have to do is we need to refer to them by addresses. That means, what is the address? Chair number 5, that's the address. So if we have to call them for lunch, we have to go to chair number 5, and then one of the volunteers will ask them, sir, please come for lunch. All right, and all the other variables who have already been assigned or reserved their places, we can call them by names, right? Professor so-and-so, please come for lunch. Professor so-and-so, please come for lunch. Because we know their names and they have been assigned from before. They have been invited from before. They are all static allocated memory. But dynamic allocated memory will not have the name because we don't know who is going to come, and we can't reserve any memory location also for them. Okay, so with this example, let's come back to our dynamic memory allocation and see. So any memory allocation which is done dynamically during runtime is put inside this heap. And as we can't reserve those chairs with a name. Similarly, all the variables which are actually allocated into the heap will not have a name. Very important. They will not have a name. So how can we actually talk to those variables and do operations on those variables? So all we have to do is using addresses. Okay, that means when a variable is allocated on the heap, so if this is the heap, and when the variable is allocated onto the heap, right, what we have to do is we have to capture the address somewhere. So where do we actually capture an address? We capture in a pointer variable. So we will have to store the address of the variable which is actually allocated into the heap, and we need to capture the address and put it inside a pointer variable. Now, once we have the address of that memory location in the heap in a pointer variable, now using star p, right, we can perform any kind of operations on those variables. So for example, if you have pointer variable p which holds the address of this variable which has a value 10, but these are dynamically allocated into the heap, then there's another variable which holds the value 5 and the address is say 105, and this is basically dynamically allocated into the heap. So we don't have names like a and b here because we can't assign names, right? But what we can do is we can store the addresses in the memory. So suppose the p is a pointer variable which is storing the address of this memory location, which is 101. Similarly, you have q, another pointer variable which is storing the address 105, which is of this memory location. So if we have to do some kind of operations, or if you have to do some kind of calculations using those dynamically allocated memories, we can easily do. So if you want to add these two, you can do star p plus star q. The sum, you will get the sum which is 15, right? So two very important concepts which I just told you. First, any memory allocation which is done on the heap is dynamic memory allocation. Any memory which is allocated on the heap will not have a name. If they don't have a name, how can they be reached? We will assign the address of that memory location to a pointer variable, and all the operations has to be done using the pointer variable. So far, so good. Did you all understand what I told you till now? Okay, fine. So
Yes, sir.
in C, you just cannot allocate memories dynamically. Okay, dynamic allocation of memory is not like how we do it in a static way. There are some specific or some functions which will allocate the memories dynamically. Okay, so there are 4 special functions available for dynamic memory allocation in C. What are those 4 functions? One of them is called as malloc. This is a function. This is the function which will do the allocation in the memory. Now, because it is happening at runtime, we need the compiler has assigned some functions to carry out that process. So malloc is one of them. The second one is calloc. Okay, it's very important to know the difference between them. Very small difference. In terms of the output of the code, no difference. But in terms of the background organization of memory, there is a difference. Then we have a very important function called as free. Okay, free. So there are 4 different functions, and the third one and the last one is realloc. So these are 4 important functions which are connected with dynamic memory allocation. All right, remember this, very important. Now, all these 4 functions are available in a header file. So they are not available with stdio.h. Okay, they are not available in stdio.h. Why? Because stdio.h is basically a separate header file which contains all the functions which are related to the input and output. Okay, but these are some library functions. These are those inbuilt utility functions. So all these files are available in a header file, std standard library header file. So stdlib. So if you're using these 4 functions in your program, please remember to include the stdlib.h header file. Okay, so let's go back to the first function and see how it works. Okay, now what this malloc does is, this malloc is a function, okay, which will allocate some memory into the heap. Now we have to specify in one of the arguments, right? We need to specify the size of that allocation. So malloc takes one argument. Okay, that argument defines the size of allocation. So if you want 4 bytes to be allocated, that means if you want 4 bytes of memory to be allocated, I need to give 4 to malloc. All right, so malloc 4 will go and to the heap and reserve 4 bytes of the memory allocation there. All right, now as you know that in the heap you cannot have a name for the variable. So what malloc does is, once malloc does the allocation of a memory in the heap, what is the size of the allocation which is being done here? Because I have entered 4 as an argument, this memory allocation will be done of 4 bytes. Okay, now after allocating 4 bytes, right, it returns the address of this allocated memory. So suppose the address is 101 here. So the malloc will return the address of that allocated memory. Now it's important for us to capture that address and hold the address and store that address, because if we don't store that address, we will not be able to reach to this variable, right? If you don't know the address of any house, you can't reach that house. So it's important that as soon as the allocation is done, malloc returns an address. So this address needs to be captured somewhere. So I will capture in a variable. I will capture it in a variable. Now this variable should be a variable which is not a normal type, but it should be declared as a pointer variable, because only addresses are stored in pointer variables. So if I'm going to store inside this dynamically allocated memory an integer, say 10, that means I have to first declare an integer pointer, right? Because this pointer is going to store the address of the dynamic allocated memory, which is going to store the address, which is going to store basically the address of this integer 10. And along with this, because I am storing the integer here, I need to typecast. Now this is not very important. I mean, in the sense, even without typecasting, it works, but you can typecast, like cast. You remember that casting is changing the type of variable, right? So if you have an integer, if you have an integer, you want to change it into a float, then you can cast it. So what I'm doing here is I am casting. So malloc will return an address. Now that address is casted to an integer type address, because it's an address, so it will contain a value of an address. It will not contain the value of an integer. That is why we are putting a star here, because we are doing a typecasting of the address, not the actual integer value. So we typecast this, but even without doing this also it works, because malloc is actually returning a void pointer. Okay, malloc is a void pointer, and void pointer can be assigned to any addresses. So if it's too complicated for you, I'm just going to write a line of code here. PTR, let's say int star PTR, right? Now, when I do PTR is equal to malloc and say 8, that's it. Okay, what it does is 8 bytes of memory is allocated into the heap, and the address of that 101 is returned by this function malloc, and that address is stored into PTR, right? So now when I do star PTR is equal to 100, I can store the value 100 inside this memory location. Okay, so you will find that the use of malloc in some of the books, it will be written something like this. Okay, just remember what we're trying to do here is, because this malloc returns an address, And now we are going to store that into an integer type pointer. That is why that address is typecasted into an integer pointer. That's all. Okay, but in your compiler, even if you don't write this line of code, this integer star also, it will work and you will get the answer, because this malloc is actually a void pointer. So you don't need to get into that. So you can either write this or you can write this. Okay, so did you understand so far what I'm trying to explain to you?
Yes, sir.
Yes,
Okay.
sir.
Okay. Now I'm going to write this line of code and I'm going to explain a little bit in more detail, because I want all of you to, understand this concept. Okay. Everybody should understand dynamic memory allocation, because this is something which I have seen a lot of people who have studied C also don't have clarity on. So suppose I write this line of code. Okay. Suppose I write this line of code. What is the size of an integer? The size of an integer, the size of, sorry, they made a mistake here. This has to be removed. You know size of operator, right? So all of you know size of operator. So if I write this line of code here, what's going to happen is the size of integer is going to be calculated. What is the size of integer depends on your compiler, assuming that my compiler has 4 bytes. So this particular line of code is going to generate 4 bytes. That I'm going to multiply with the value 5. So this becomes actually 20, right? So what malloc is going to do is, it is going to allocate a 20-byte memory. It's going to allocate a memory of size 20 byte, right? And it is going to store the address of that into PTR. All right. And whatever the content inside this, nothing is added, and this will contain garbage value. What is garbage value? Garbage value is basically that value which the previous program has left. What it means, like suppose, you are staying in a house, a rented house. Now you move your house and you shift. So what you do is you take up all your important things and go. But there will be few things which you would have left. For example, there's an empty bottle. I know you will not, you'll just leave it there in the house. You say, who will take this? Let it be. I don't need to use it. You'll find that there's some pieces of paper. There are some plastic bottle caps, some of your stuff which is not useful to you. So you'll just dump it in that old house and you will walk away. So the second person, when he comes, and for him, if that house is allocated or if that memory is allocated, then he will find the remains of few things which the previous program has left, right? That is nothing but the garbage value. So when the malloc function allocates memory, right? In this scenario, it will allocate a 20 byte of memory and it will assign it to the pointer variable PTR. And if you try to print the contents of this PTR, it will print a garbage value. Some random value will get printed. Okay, so this is how a malloc function works. Now, you can use this malloc with an array as well. Now, what is the difference between malloc and calloc? Now, the calloc function, on the other hand, right, is similar to a malloc, but the calloc takes 2 parameters. So let me just write this. Let me just write it. So what's going to happen in case of calloc? So if I write the same thing with calloc, let me just erase this. Okay. So if I write PTR, I'm changing the name from malloc to calloc. Now this accepts 2 arguments. Okay, what are those 2 arguments? First, it will take the block size. This is the block size. Okay, and the second one is the size of integer. Let's say the same example I'm taking. Now, what is this going to calculate? This is going to calculate the size of an integer. So in my case here I've taken 4, so I'm taking 4 here as well, right? Now what this calloc is going to do is it is going to allocate a memory location of 20 bytes, but it's going to divide these 20 bytes into 5 blocks. That means it's going to have 5 blocks, 1, 2, 3, 4, 5. And each of these blocks will be of size 4 bytes. So it's 4 into 5 blocks, which is equal to 20. And what this calloc will do is, it will initialize all these blocks with 0. Did you understand?
Yes, sir.
Okay, so there is a difference. So if you try to allocate a memory, into calloc or using malloc, both of them are going to allocate 20 bytes of memory, but in the calloc it is going to create 5 blocks of 20 bytes. Okay, whereas in case of the first malloc, it is going to create a single block of 20 bytes, and this is going to contain garbage value. But in case of calloc, it is just going to have, it's going to initialize it. That means it's going to clean up the memory also. What calloc does is, it doesn't do only the initializing, but it also initializes and cleans up the garbage. Okay, and by cleaning the garbage, what it does is it allocates 0 and keeps it there. So those are the two difference between a calloc and a malloc. So I hope all of you understood the difference between calloc and malloc. Right now, the third, if you go to the previous page, I had told you about free. What this free is going to do is, once you allocate the memory, right, it's also important that before you finish the program, you have to remove the allocation. That means whatever you had reserved dynamically, we need to free those memory, because if you don't free it, they will get locked, and it will, it will be like reserved even after the program has left, and then it will basically kind of consume that space, and the resources will not be freed. So after we finish calloc operation or malloc operation, just before we complete the program, we can use the free method to free the allocated memory. So how do we write the free method? It's very simple. So this PTR is basically pointing to the memory location which has been allocated dynamically in both the case, right? So we will pass the PTR, the pointer variable, which is holding the address, and that's it. This is the simplest line of code that you can write. So once you do this, whatever allocation you had done in the program, that will get freed. Okay, so this way what happens? Whatever dynamically allocated memory is not automatically removed. Remember that. Since you are allocating the memory at runtime, right, it is your responsibility to even remove that memory or clean that memory before you go. So as a good programmer, if you are declaring calloc or malloc in your code, you must use free, right, to remove the memory locations. Now the third one is realloc, and I'm going to very easily explain that realloc function. So suppose we have a pointer variable here. I'm writing the same piece of code. It's a redundant code. I'm writing multiple number of times, so you should be able to understand this. Okay. I think somebody's microphone is on. It would be nice if you can just switch it off. Thank you. So here is my line of code, right? By now you must have understood what this line of code means. Again, the size of integer will be calculated as 4, and you have 5, which is basically a number. 5 into 4 is going to be 20. So you have a pointer variable PTR, which will be pointing to the 20 bytes of memory, which is allocated by malloc, right? Now suddenly, while the program is running, we have this 20 bytes of memory, and now the requirement is that I need to increase the size. Maybe I need more size. I need more, for example, in the array, when I was talking to you about an array, that suddenly if you want to increase the number of elements in an array from 9 to 12, then you have to add that extra 3 elements into an array. We need to increase the size of an array by 3. Similarly, in this case, if I have an allocation, initial allocation is done as 20 bytes, and during the running of the program, suddenly I realize that no, I need 40 bytes. So what do I do? Right? So in that case, I will be using this function called as realloc. Okay, what this function does is very simple thing. All I need to do is give this pointer, write this function realloc. Okay, and in this I will pass the pointer variable, this which is actually pointing to this memory location, right? And I will increase the size. So if I want to increase the size to 40 bytes, right, I can straight away write 40 here, or I can do like, I want to double the size, so you can do anything here. You can just write 40 also, it will work, but here I'm doubling the size by taking the value from the size of integer. Now what is going to happen here, right? This function is going to double the size of my memory. Now this was 20 bytes, but here it is 10 into 4. What's going to happen? 40 bytes. So here BYT as 40 bytes of allocation is done, and PTR still points to this. Okay, so that's how your realloc works. So reallocation is done just to increase the size of an already existing dynamically allocated memory. Now remember, this realloc will not work on your other statically allocated memory. These will work only if your variables are dynamically allocated. So what I'm going to do here is just revise these 4 functions today, and tomorrow I'll write a program and show it to you. In fact, do we have some time? Whose class do we have now? You don't have a class, right?
Yes, sir.
We have a
No,
class.
sir.
You have a class now?
Yes, sir.
We have a
But 12 o'clock your class gets over, right?
No, sir, we don't have a class.
Rearrange or
we have
CSR just we have some
Whose class?
stuff.
we have CA. It was
Oh, so you have
it was
CA.
supposed to start. Yes.
Okay, but in the timetable you don't have, right?
Yes, sir.
Okay, then I can take 10 more minutes. Okay, 10 more minutes. I'll write a simple program and I'll show it to you so that you can be more confident of what we just did. Just give me 10 minutes and then we can leave for the day. So I'm just going to write a simple program, and I'm going to write a program where you all are familiar with arrays, right? So let me write a simple program and show you how we can allocate memory dynamically, and I'll be using Malloc. I can also use Catalog, but it's the same thing, okay? So there will be no difference in the usage, right? So I include my stdio.h. Now, let me just change the color of this font to black. Okay. Now, I told you that if we are going to use those 4 functions which are going to help us in dynamic memory allocation, what we need to do? We need to also include which file? stdlib. Right? Absolutely. So remember that. That's very important, because many of the times students write the program and they say it's not working, and then they would have forgotten to put this stdlib. So here we go. Sorry, I need to first write the main method. Okay, so here is my int main. All right. Now I'm declaring a pointer variable. So here's my pointer variable. Okay. Let me declare 2 more variables, like let's say n, and let me declare another variable to run a loop, because I'm going to use an array I. Okay, now this n, now this way I can also ask the user to enter the size of my array. Now that's amazing, isn't it? All this time what we have been doing is we have been setting a size before actually running the program, and then we've been kind of putting the elements into that array. Now, for example, suppose I am running a program where you can enter, say, 10 numbers or 15 numbers. So rather than making it fixed size, I can ask the user, tell me what size you want to enter, tell me how many numbers you want to enter. So if the user says 5, we will allow the user to enter 5. right? So assuming that you can, let me put a value n is equal to 5 here, but I can accept this value from the user also. Can I do that using scanf?
Yes, sir.
I can, right? So using scanf, I can take the value of n, anything that the user wants. So right now I have taken it as 5. Okay, so this n is basically my number of elements that I want to have. Okay, now let me declare this pointer. So pointer is already declared. Now I'm taking this pointer variable. Now I'm going to allocate memory dynamically. So here is my malloc function, right? Because n is equal to 5, right? That means I need 5 integers. So this is going to tell me that I need 5 integers, and each of those 5 integers I need size of integer. Okay, I hope you're understanding this line of code. Simple. Because I want to enter 5 numbers, that's why I have written n, and each number will be an integer. So I need to allocate a memory location. That means 5 integers, and each integer will have 4 bytes, which is equal to 20 bytes. So n value here 5 will become 20 here, and because this is a pointer, I need to just typecast it to pointer variable. So what this does, it will create a dynamically allocated memory of 20 bytes. Now, one important thing which I forgot to tell you is that if in case there is no memory available, what will happen? Suppose it's trying to allocate the memory, but there is no memory, there's no space available. So how will that allocation be done? So if there is no space available, what the malloc will do is it will return null. Okay, that means if the allocation is not possible because of memory issue, there is no memory to be allocated, it's all full, then the malloc does not return the address, but what it will do is it will return null. So it's very important to check whether the memory has been allocated or not. So if the malloc returns null, then memory allocation was not successful. So we will, every time when you use malloc and calloc, you need to check if your pointer has null value or not. If your pointer has got null value, that means you can straight away print and tell the user that allocation unsuccessful for some issues, and most of the time it's memory not available. Okay, and once it is unsuccessful, you can basically exit the program by using this exit function. Okay, in case it does not return null, right? But what it does is it returns an address. That means memory has been successfully allocated. So else means it did not return null. That means memory has been allocated successfully. So what do we do there? So now inside this else, okay, I'm writing a block here and I'm writing this here. Okay, all the code which is supposed to be here, I'm writing it here because I have some space. Let me run a for loop. So I have declared that I on the top. So I will start I is equal to 0, and I will be less than what, 5 numbers, right? Because I have given n, so I will write I is less than n and I plus plus. You know this part, so I'm not writing anything here. And then what I'm going to do here is ptr. Now this is ptr will be holding the address of that memory location, right? So you know that a pointer, an array, the name of an array and the pointer variable is the same, right? I have explained it to you that pointers and arrays have a very strong relationship. That means the name of an array is nothing but a pointer, right? So what I can do here is I can do pointer I is equal to some value you can store. So let's say I plus 1, that means it will store the value 1. So this way, what's happening is PTR is basically by using the value from I will be from 1, 2, 3, and 4. I will have 5 values. That means I can enter those 5 values as an array, right? PTR 0, PTR 1, PTR 2, PTR 3, PTR 4. and each of those memory locations, I'm actually initializing the value 1, 2, 3, 4, 5, because 5 times it will run. And now I can use another for loop, and I can print the value that is being stored into PTR, and I can store it. I can do PTR I, and I can print the values. Okay, so this is a simple program. What this program does, it just allocates the a memory of size 20 bytes, and in that 20 bytes I store 5 integers as an array, and using PTR I can access those integers and I can also print them. Okay, so just try to go through this, write this program yourself, because of lack of time, I have just roughly written it so that you kind of understand. But the most important step is this one. So what you need to do is just look at these 3 steps here. I'm just going to highlight it, and these are the steps which are important. Okay, PTR is equal to malloc function, and check if PTR is equal to null, then don't do anything, exit. If PTR is not equal to null, then you can actually run a loop, and inside that loop, using PTR 0, 1, 2, 3, 4, 5, I can declare 5 integers, and then I can access them just like how I access an array. Okay, the same program can also be written using Calloc. So if I need to change this program using Calloc, I don't have to do anything different here. I don't need to do anything different here. Only what I need to do is change this malloc and write Calloc, and this program will run exactly without any differences. Okay, so you can all start giving your attendances. I think you're already given. All right, fine. So we will stop here, and we will continue in the next class.
Thank you, sir.
Okay, so you can leave and go for another class.
Thank you, sir.
Okay, bye.